Okay, were you guys all able to install bed tools? Let's start there. Raise your hand if you could not install bed tools. No! How'd you try it? Use Conda. Did you try Conda? Conda install? Okay, sounds like most of you got the bed tools installation. That's great. How's the documentation bed? Can you guys follow it? Yeah? Bed tools has pretty good documentation. I really like it. It's easy to read. Okay. So for the bed tools dash flank options, or bed tools flank, what are you guys using? So you have this dash I. So what are you guys giving it as the input? Anybody? Yeah.
You find the file that we transferred over, that's the transcript.
Okay, so we're trying to flank the upstream of our transcripts. So your input should be the transcripts that we've made. And it's telling you here the different options that you can give it for an input. GFF is essentially the same thing as GTF. So that should tell you here that, okay, I can give it my GTF input file, and this is the file that you made with the transcripts, .gtf, for chromosome 22. And you made this using awk, or if you didn't make it, it was in the folder. So this is your transcripts, chromosome 22, GTF file. Okay. What are you guys giving it for the genome? HG19, just like those 4 letters, or HG19. Okay, and how did you know that that was the one that you needed to use? Because I put it in there. Okay, so some people were getting confused and saying like, oh, genome, that sounds familiar. I'm going to provide it the genome annotation that we had. And a lot of times whenever it has these flags, it'll give you more information about how you know what you need to input in there. If you read up here, it tells you that it requires a genome file defining the length of each chromosome. So if you're trying to input the GTF file here, that should be a warning to you that that's not going to be the right thing, because you know what a GTF file is. You know that the GTF file is defining the regions of genes and exons and transcripts, and that has nothing to do with the size of the chromosomes. So there's information in there on where we got this from. You could always Google, where can I find a size of all the chromosomes for HG19, and there is a file with this information in the shared folder. Okay, what other options are you guys using? Dash L. Great. Okay, so what are you putting for dash R? Cool. And that was what? Okay. Did you guys use dash S? Why did you use it? We do. So you have to keep in mind where the stranded information is coming from. We're looking at gene transcripts. Gene transcripts are transcribed in both directions. If we want to go upstream of the transcript, we need to specify if that transcript is on the positive or negative strand, because upstream, this is why the RNA field is really annoying. You always run into this nonsense, but let's take care of it. So if the genome direction is this way, and you have a gene that's being transcribed in this direction, upstream of this gene is here. But if you have a gene on the opposite strand and it's being transcribed in this direction, by convention, we always label, this is position 0, 1, 2, 3, 10, whatever. We always label in increasing order, but this gene, so this gene is going in this direction, therefore this is upstream and this is downstream. But if I have a gene that's on the reverse strand and it's being transcribed in this direction, now for this specific gene, this part is upstream and this part is downstream. So there's the way that programs handle this is if you input stranded information. So in our transcript file, we have stranded information. So you guys can use that to specify that upstream is relative to the strand. Any questions? I see confused faces.
So would you use that with Alibar or?
Yes. So, okay. By convention, start is always lower than stop in a bed file. So for this gene, my start position is going to be 1 and my stop position is, say, 9. And for this gene, maybe my start position is 2 and my stop position is 10. But you'll notice my start position is actually the end of the gene because it's on the reverse strand. And this is just a naming convention and how they always do it. So when you're saying -L, you're subtracting these from the start coordinate. So -L is this start coordinate, we're going to subtract in this direction. If we don't specify stranded information for this feature, we're also going to subtract in this direction, and that's a problem. So when you specify stranded information, it's telling the program, hey, if I have a negative strand, flip it and subtract that 2,000 from this direction, or actually add 2,000. So when you're the one who has to write this code, it's really annoying because you have to make sure your pluses and minuses are in the right direction and in the right spot. But a lot of programs that are out there specify this, and they just let you input the strand, and it will automatically do the opposite math for you. So with this GCF file, we have stranded information, so it's great to use it. Yeah.
the first one was 2000.
Uh-huh.